In this video, we look at classifying general types of chemical reaction before focusing on chemical reactions that occur in aqueous solutions in following videos. It turns out that chemical reactions generally show a well-defined pattern of behaviour and that broad commonality of chemical reaction types are apparent. And we're already familiar with these ideas with respect to combustion reactions, which we've met previously. Combustion reactions are reactions between a combustible substance with molecular oxygen that results in the formation of various products with a concomitant release of energy, usually in the form of heat and light. The general class of combustion reactions that we have met already is the combustion of hydrocarbons, compounds that contain only carbon and hydrogen, which react with molecular oxygen to produce carbon dioxide and water. And you may recall an example we saw earlier with the combustion of propane, C3H8, where we were able to write down an unbalanced chemical equation based on the general reaction pattern, and then we could subsequently balance the equation by placing the appropriate stoichiometric coefficients in front of each substance. It turns out that a much broader range of compounds will also burn or combust in the presence of molecular oxygen to produce carbon dioxide and water. For example, compounds that contain only carbon, hydrogen, and oxygen will follow this same general trend. And these substances include many millions of compounds from broad classes of compounds such as carbohydrates, alcohols, organic acids, aldehydes, ethers, esters, and so on. And once again, when given a specific compound, such as glucose, we are able to write down an unbalanced chemical equation for the combustion process from our knowledge of the general reaction pattern, and then subsequently balance the equation by placing the appropriate stoichiometric coefficient in front of each substance. In addition to combustion of organic compounds, a whole range of inorganic combustion reactions can also take place between, for example, metals and molecular oxygen, for which we can also write balanced chemical equations. It turns out that most chemical reactions can be classified under four general reaction types: combination reactions, decomposition reactions, and two types of displacement or exchange reactions known as single displacement reactions and double displacement reactions, which are also sometimes referred to as metathesis reactions. Combination reactions involve two or more elements or compounds coming together to form a larger compound or compounds. And the classic reaction that we've encountered several times before, the formation of the ionic compound sodium chloride, falls into this category, where the elements sodium and chlorine combine to form solid sodium chloride salt crystals. Decomposition reactions involve compounds splitting into two or more compounds or elements, with a common example being the ionic compound calcium carbonate or limestone decomposing to form two different compounds, calcium oxide and carbon dioxide. Displacement reactions or exchange reactions involve the displacement or exchange of parts between reactants. So, for example, if we consider the general reaction scheme shown here for a single displacement reaction, A plus BC going to AC plus B, we can see that the element A displaces one of the elements in a compound to form a new compound, AC. At the same time, element B is also released as another product. As I said, this is a single displacement reaction as there is only an exchange or a displacement between one part of the reactants. We can also have double displacement reactions, also known as metathesis reactions, illustrated by this general reaction scheme here, where the compounds AB and CD react to produce the compounds AD and CB. And what we see here is that element A displaces element C to produce the compound AD. And at the same time, element B displaces element D to form the compound CB. It turns out that most chemical reactions in aqueous solutions are some type of displacement reaction, either a single displacement or a double displacement reaction. And in following videos, we will look in more detail at broad reaction types in aqueous solutions, such as precipitation reactions, acid-base reactions, otherwise known as proton transfer reactions, and redox reactions, otherwise known as electron transfer reactions.